Myself Syed Shah Abdul Salam, Assistant Professor, Department of Pharmaceutical Chemistry. Today we are going to discuss about geometrical isomerism as well as method of defining of conformations of geometrical isomerism. Let us start. Coming to geometrical isomerism, this is a method or a phenomena in which there is a restricted rotation around a double bond. So in this, if you see, the molecules will have same molecular formula, but they differ in the spatial arrangement around a double bond. If there is a double bond or if there is a higher molecules with a restricted rotation, then you will be exhibiting this geometrical isomerism. Let us see few of its different types of various geometrical isomerism. Coming to the first type of a geometrical isomerism, that is cis and trans isomerism. So here, cis and trans isomerism, it should have two different molecules on double bond. So on the double bond, two different molecules, if they are present, then we would be giving this designation of cis and trans on what basis? If the molecules, if they have same molecules, if they are present at the same site, this is different molecules are present. Okay, so in this you can see this geometrical isomerism that could be possible. But here, if you see, the molecules are total same. Okay, so here no geometrical isomerism can be possible for the first example. First of all, carbon must possess two different molecules on each double bonded carbon. They must be two different molecules. If they are having the same molecules, then it doesn't have that geometrical isomerism occurring in that. Okay, now let us take an example for cis and trans forms. So here in this cis and trans forms, if you see the molecules when they are arranged on the same side of the double bond, here you can see that cis 2-butene dioic acid, when it is having two carboxylic acid which are arranged on the either side, same side, we call it as cis form. When it is arranged on the opposite side, the carboxylic acid is arranged on the opposite side, we call it as trans form. And this trans form and cis form, they are two different type of acids. They have two different names. Trans form of 2-butene dioic acid is regarded as fumaric acid, whereas cis form of 2-butene dioic acid is called as malic acid. Okay, so these are the derivatives of butene dioic acid. When the arrangement is cis, that is regarded as malic acid. When arrangement is trans, it is regarded as fumaric acid. And another example it has been given about cis butene and trans butene. So you can see that in cis butene, both the methyl group are arranged on the same side of the double bonded carbon. If the methyl groups are arranged on the opposite side, we call it as trans form. So here in this you can see that if the molecules, if they are present, like the above examples which are here given, like how to give the cis and trans forms. So like if the molecule, if it is having all the hydrogens and all, then it won't be having this cis and trans sort of arrangement, because it should have two different. So no possibility for this. Okay, if it is having four different molecules, like if it is having two same molecules on one side, here also two same molecules. So in these examples you can see that carbon atom is having same molecules at a specific site of or a specific carbon. So no geometrical isomerism can be possible for this. Okay, so here it should be having a restricted rotation. Okay, then only we can be giving it as the naming. Okay, so here now it has given few examples. Like in this example, this is cis form because A is arranged on the opposite same side, B is arranged on the same side. This is trans form. In this, A is arranged on the opposite side and B is arranged on the opposite side. Okay, so here this cis and trans, it is restricted or has limitation. What limitations? Like it can be used only for two substituents. If it is more than two, we cannot designate cis and trans form. So in this, geometrical isomerism possible, but cis and trans cannot be used. So this limitation had lead us into a new representation to show that arrangement. Like here you can see that there are three different molecules which are existing or present on the double bond, like A, then we have and we have B. So here this B and D are different molecules. So that is why we cannot apply the cis and trans form to this. Okay. For that, we need to use a different representation in which we can use or elaborate this geometrical isomerism into the various compounds or carbon bonded compounds which are having more than two substituents on the double bonded carbon. So that arrangement is called as E and Z. Okay. So here it has given few more example for the understanding of cis and trans forms. So we'll discuss about where or which sort of arrangement can be used for these molecules in which you can have three different molecules on the same double bonded carbon. We will discuss after this cis and trans about that type. Okay, let us take few more example to understand this cis and trans isomerism. So here it has given example for cis 1,2 dichloroethane, trans 1,2 dichloroethane. So you can see that chlorines are on the opposite side for the trans, whereas chlorines are on the same side for the cis. Like again another example is cis isocrotonic acid, okay, in which the hydrogens are on the same side, and here if there is a methyl and carboxylic acid, so here if there is a hydrogens on the same side, we will be giving this cis and trans. Okay, so this is also a type of cis and trans isomerism that can be applied to it. Coming to this another example here, like if both the molecules, if they are present on the opposite side, they are regarded as trans, and if they are on the same side, they are regarded as cis, like more than two, even if it is there. If same hydrogen or one molecule, if it is there, by taking that single molecule, we can designate cis and trans if that single molecule is present on the same side or in the opposite side based on that. Okay, so even we can use it for three molecules. We have seen a few examples here. So like example for cis isocrotonic acid, in which you are having hydrogens as well as carboxylic acid and methyl. So this carboxylic and methyl are different molecules, but still when they are present on the opposite side, by seeing where the hydrogen are present, we can designate cis and trans to this. Okay. Similarly, we have one more example of cis 3-hexene and trans 3-hexene. In this, we are seeing about methyl moieties, and we are seeing that how the hydrogens are arranged. If the hydrogens are arranged on the same side, then it is given the cis designation. When they are arranged on the opposite side, they have given the trans designation. Now, last example which is mentioned here is of oleic acid. So, oleic acid can also be have two isomer. So, this the cis form is called as oleic acid, in which both the hydrogens are present on the same side, whereas the trans form is regarded as elydic acid. Same molecule, same structural formula. If you see that the molecules or number of atoms and all, that will be same, just the difference is of arrangement of hydrogen atom. If it is on the opposite side, we give it the trans form. So here